Okay, question number 5. Here's our formula. P equals 1,350, etc. with a minus t up there. Okay, a minus t as a power, it's an exponential graph. Okay, this is because it's a minus up there, it will be a decaying one. All right. The 1.25 will tell you the steepness if we need it. The 400 stretches it a bit, and the 1350 lifts it up. So maybe we'll have a look at what that graph looks like in a bit. But essentially, we just need to use the equation. At the start of the migration season, that is meaning where t equals 0. Okay, so there will be a 0 up there. If anything has got a 0 for a power, then the answer to that is 1. So the 1.25 to 0 is a 1. Here it comes. There it is. Okay. And then you've got 400, add 1350, gives you 1750. Part 2 wants it after 5 days. So all you're doing there is you're putting 5 up here as your power. Type that in your calculator. You come up with 1,480. Okay, and then part B, calculate the time taken for the population to decrease below 1,400. Okay, so you want the P in this one to be equal to 1,400. There it is in the equation. Okay, 1,400 equals 1,350 plus 400, 1.25 to the minus T. Now this can't be rearranged very nicely to give you an easy way of solving the algebra. So there's any equation where there's one thing unknown can be solved by your calculator. The only thing we don't know in our equation is a t. So we can use our calculator using the nsolve function. Okay, and here's my calculator. Nsolve can be found. So I just want to go onto a calculator page. Okay, I go menu, algebra 3. Numerical solve 1, and then it comes up with the nsolve. Okay, I think, have I done it up there? There we go, look. Okay, it's that one there. You type in nsolve. You need the comma t at the end because we put using t as the variable. If the t was an x, you put comma x. If the t was an r, you put comma r. But essentially your calculator will come up with 9.31, etc., which on the front cover of the exam paper, look, okay, it says, unless otherwise stated, all answers should be given exactly or to 3 significant figures. Those are your 2 choices. Okay, so big long decimals probably given as 3 significant figures. Answer comes out to be 9.32. Okay, let me just find the question again. Here we go. Okay, so right, like I say, we did have an exponential decay curve. It does say that we did find that the initial value, look, is 1,750. We found that in part A of the question. All right, but this graph decays away and has been shifted up by 1,350. So the asymptote there is that y equals 1,350. You can draw this graph on your calculator, and then you'll be able to identify where the asymptote is, the lowest value that it could possibly be, or getting towards, when is 1,350.